Yes, welcome you all. So today we're going to discuss about the torsional. So this is about a model for the about the torsion. So mainly the thing is what we're going to discuss about in this torsion is about we're going to discuss about the what is the torsion, how the torque will be generated, where exactly this torsion will come into the picture. Then we're going to discuss about the assumptions, what the things we're going to assume for the torsional. Then we're going to derive the equations. Then we're going to solve some of the few numerical examples about the torsional. So torsional related equations, and we're going to solve about the torsional problems. First, when we yes, now we'll discuss about the introduction to the about the torsion. Mainly, the shaft torsion is nothing but wherever the torque is going to be, the power will be generated with the rotational of the shaft. See, the torsion will come into the picture only when it rotates or when it starts rotating only. So first we're going to discuss about the brief introduction about the how the torsion will come or how we can able to consider the torque or a torsion. So first when we discuss about introduction, first when we come to the introduction is nothing but a shaft is a straight bar usually of a circular cross section. So the mainly when we going to consider any shaft, the shaft will be always in a straight circular cross section. So in the few cases whether it might be in a solid shaft or on the hollow shaft. So whether the solid will based on the requirement where we're going to use as in a solid or in a hollow shaft. But whichever the shaft we consider whether a solid on a hollow or in a solid shaft, so it will be always the shaft will be a straight bar usually with having in a normally or generally it will be in a form of circular cross section only. So the mainly the shaft where we're going to use that shaft. The shaft is used to transmit the so the power is transmitted from motor to compressor with the help of the shaft only. The power can be transmitted from motor to the compressor. Again from compressor to the turbine. Again with the help of the shaft only the power can be which is the transmitted from power from motor to the compressor. Same power again can be transmitted through the shaft itself only from turbine to the generator. So from motor to pump. So like this all the mechanical components mainly the shafts is being used even in all the engines also. If you take any engine it can able to convert the from one motion to other motion with the help of the shaft only. So whenever the shaft rotating even you can able to see in the power plants also the shaft used to transmit the power or which is a power transmitted or which is the power generated which can able to transmit from one component to other component in order to run the machine properly. So like this for example even if you can take also belt drives. So even there also shaft has been connected in order to transmit the power from one wheel to the other wheel. So the direct connected connection will be there between the two wheels. So with the help of the shafts rotate only automatically the power will be transmitted from one wheel to the other wheel. So like this even in the belt drives or in a chain drives all the way they have been connected with the shaft in order to transmit the power or even it can give an emotion from one component to the other component. So this is the major use of the shaft. So as we told, the shaft is mainly based on a circular cross section, or it is used in order to whether it may be a hollow shaft or in a solid shaft. Based on the requirement, we're going to consider this. And even in all the engines, whether if you take in a small car to the even the large, all the large heavy vehicles also, the shaft will be there in order to convert the motion from one point to the or one component to the other component. So next, the two equal and opposite couples acting about the axis is gives the rise to torsion. Till now we have discussed about the function of a shaft. Now we going to discuss how the torsion will be or the torsion will be generated. See, whenever the two equal and opposite couples acting about the axis. See, whenever we are going to consider any two equal and opposite couples acting about the axis to give the shaft will rise or shaft will generate that torsion at that particular point. So even the torsion also is known as a twisting moment. The twisting moment is nothing but both the ends cannot able to if the both the ends of the shafts will rotate in opposite direction at one particular point the torque or the twisting moment will take place. Exactly at that particular point some angle will be developed based on that only the twisting moment or the torque will be developed. Due to this torque every section of the shaft is subjected to shear stress. See, whenever the twisting movement takes place, the because of the how the twisting movement takes place is nothing but because of the load. Whenever the load is acting, whether it might be in a tensile load or a compressive load or a bending load or a twisting. Twisting is also one of the type of load on that particular section where the twisting movement exactly happens, where the on that particular section of the shaft is subjected to the shear stress. Yeah. So the shear stress will be developed on that particular shaft. So based on this only we can able to identify the twisting moment, and we can able to identify the shear stresses, and even we can able to identify the diameter of that particular shaft, or we can able to identify the angle of the twist at where exactly the twist is. Based on all this only the torque will be developed. Based on these conditions only we can able to identify all these details. So this is about a shaft. So next we're going to discuss about the torsion. What do you mean by a pure torsion? Till now we have discussed how the torque will be developed whenever the two equal and opposite couples acting about the axis to give the rise to the torsion, and the twisting moment, the torsion is also known as a twisting moment, which takes place the twisting moment, right? So now we're going to discuss about the pure torsion. What do you mean by a pure torsion? A member is said to be a state of pure torsion if it is subjected only the torsional moment. See, only when we can able to consider the pure torsion means only the twisting moment or only the torsional moment is applied, then only we can able to consider that as a pure torsion. No other forces will be acting, such as a bending force or an axial force. No other forces will be there, only the torsional moment or a twisting moment. Because of that only the what the torque is developed, that only we will consider that as a pure torsion. So this is about the difference between the torque, general uh, torsion, and a pure torsion. So next we're going to discuss about the assumptions in the theory of pure torsions. See, whenever we're going to follow about the pure torsion, so we're going to follow the some of the assumptions. Maybe the material may obey these assumptions, or in the few conditions the material may not obey this all the requirements of this assumptions. What? So that is the reason. So we are assuming this. These are all the conditions of where the material is undergoing through the theory of the pure torsion. Whenever the torque or a torsion is developing, we are going to assume, means basically in the terms of an industrial knowledge, in terms where these are the materials has to undergo all these conditions, then only they're going to select the materials for the different purpose. But whenever we are going to develop, or we're going to generate the equations, or we're going to derive the equations, we are all considering this as some of the assumptions that material obeys all these laws. So only it is subjected to the pure torsion. First one is about the material of the shaft is homogeneous, isotropic, and the material shaft is uniform throughout. See, the material of the shaft is homogeneous and isotropic. So homogeneous is nothing but wherever I am going to measure from any part of the component or in a material, the properties will be same. The composition doesn't varies. So if a material, if I measure from any end or any point, or at any point or any part of the material, it obeys, means the composition of the material will not vary. So the whole composition will be there same throughout the entire shaft material. Isotropic. Isotropic is nothing but the properties will not vary from any point of the material. If I am going to measure at starting end, and if I am going to measure at the bottom last end, so all that the properties will remain same throughout the material. So means the which are the material we are going to select for the shaft, they have to obey all this, means the composition or the properties should be remain same throughout the material. So the material of the shaft is uniform. The material should be of the shaft should be uniform throughout the process or throughout the conditions. Next one is about the second assumption is about the normal cross section of the shaft, which are plane before the twist remains the plane after the here. Even the normal cross section of the shaft also will remain the same, even that before the twist and after the twist no wrapping takes places. Wrapping is nothing but where the twisting moment will be same constant, even the after the removal of the load also it will be same only. So the next one is about the shear stress is proportional to stress, and hence the material should obey. So here also the material which we are going to select should has to obey the Hooke's law. What do you mean by Hooke's law? Hooke's law is nothing but where stress will be directly proportional to strain within that elastic limit. So within that elastic limit is nothing but whenever we are going to apply the load, after removal of the load, the material can able to regain its shape or original size or a structure even after the removal of the load also. So that is what we call it as a Hooke's law, means the shaft which we are going to use, that material will should obey the Hooke's law, means what that this assumption indicates, even after the removal of the load on the shaft also, the shaft should be able to remain to regain its shape or a size or any structure after once the removal of the load also, right? And the next one is about the twisting along the shaft will be uniform. Always the shaft will be uniform only. Uniform is nothing but it should be in the continuous process only. Next one is circular cross sections remain